Hey guys, hello everyone. This is Nurul Huda and I am a verified educator at an online learning platform that is an academy. You can access my videos over there as well. So if you are preparing for CSIR NET, GATE or IIT JAM, any of these exams, you can access my videos over there as well. These are going to be very helpful in your preparation, right? So in order to access my videos, what you have to do, you have to download this Unacademy Learning app and you can search for my name, that is Nurul Huda, or you can go directly to my profile from the link given in the description. That's all for this. Let's continue with the video. Hello everyone and welcome to the channel. So this video is going to be about your revision of organic spectroscopy, right? So what I have done, I have taken out around 10 to 12 questions are there in this particular video, and I have solved them, which are on your previous years questions are there basically, and they are from your organic spectroscopy. So they are basically from different topics, that is from NMR, then your IR, and also from your mass spectroscopy also. So actually I have taken for some special classes depend like on this particular topic, that is organic spectroscopy, but many of you were not able to attend it, and I want that each and every of you get benefited from this. Okay, so although you were not able to attend the special class, I have taken out few questions from that class and I have re-recorded this. Like it took a lot of time for me to record like that, but yet I have done all these things for you guys. So enjoy the video. In the upcoming slides we are going to get questions and I will be solving them, and I hope you guys will enjoy this. And there are around 10 to 12 questions, so each question are from different topics, like your depth is also covered over here, then your IR, different topics of IR, mass, microwave, all of these, like basically from all the mixed questions from your organic spectroscopy I have taken. Okay, so enjoy the video, enjoy the slides, and like the video if you have like if you like the teaching skill, if you like what the content is provided to you, give a like to this video. Okay, and if you are new to this channel, I will suggest you to subscribe it, because I post very helpful things related to your CSI net preparation, gate, and also for IIT JAM also I'm going to start soon, right? So this video is because exam is very near and it's high time. I just want every one of you to get benefited from this. I just want everybody, so that you don't miss out any question from this organic spectroscopy. Okay, so in the further slides we will get questions and I will be solving them, so enjoy them. So let's talk about this question. Over here it says that among the following compound that displays IR band at 2150 centimeter inverse, right? So it's quite a big value, that is 2150 centimeter inverse, and we all know about this thing, that IR band are because of bond stretching, right? So bond stretching, basically they give you bond stretching frequency. Okay, so they come because of if you have a bond, let's say we have a bond between A and B molecule. If this bond will be stronger, so the more the bond is stronger, the higher the IR value will be. Okay, so this IR value depends on how strong your bond is. Okay, so that's why your like carbon carbon single bond will have lesser IR value compared to carbon carbon double bond, and that will be lesser as compared to carbon carbon triple bond, right? So you just have to think about like the bond order. So bond order is directly proportional to your IR band value. Okay, so IR band value. So band value over here is nothing but 2150 centimeter inverse. So over here if you'll see all of this molecule, so here you have a double bond. Okay, so you have a double bond and that's why you will get a IR band due to this double bond. Over here also you have a double bond, but in this molecule if you'll see, if you draw this molecule, so it will look something like this. You have a benzene molecule, something like this, and then you have nitrogen, then you have this nitrogen and triple bond nitrogen. Okay, so it will be something like this. Okay, so yeah, so this is how this molecule will look like. Okay, so this third one, so since you have a three bond like nitrogen nitrogen triple bond, so that's why these nitrogen nitrogen triple bond actually gives you higher band between around this region, that is 2150. So the correct option for this question basically will be your option number 3. Okay, so this is all because of this nitrogen nitrogen. So wherever you get this N3 kind of thing, so their IR value will lie more than 20,000, like more than 2000 centimeter inverse. Okay, it's quite big value, and this is because this bond is very strong. as compared to the other ones, right? So in this question it says that the correct structure of the compound which shows 13 carbon NMR depth. Okay, so you have depth data, depth 135 data. Okay, so the data is like this. You have negative peaks as at these four values and positive peak at this value. So before going into this, before solving this question, I'll just like to inform you a few things regarding depth signals. So basically your depth is of three types. Okay, so you have either depth 45, okay, you have depth 90, then you have depth 135, right? So what are these depth signifies? So depth 45, for depth 45 what it will do, all signals, it will show you all signals and those all will be positive. Okay, so all signals, it will show all the signals, all kind of carbon will be shown over here, like all will be represented over here and all will give you positive signals, where while your depth 90 will only gives you only like sorry only it gives signals for your CH group. Okay, so it will just give signal for your CH group, while your depth 135 what it does, it gives you two type of signal. First is for CH2 groups, for CH2 groups it gives negative signals. Okay, so it gives negative signals for CH2 groups, whereas it will give a positive signal for your CH and CH3 groups. So if you have CH or CH3 groups, you will get positive signals. Okay, so this is how all these depth work. So over here you have four negative peaks, means you have four CH2 groups. Okay, so four CH2 group, in which molecule you are going to get four CH2 group. So in first one, see here you are having CH2, at this place it should be CH2, here also CH2 and here also CH2. So in this only you have four CH2 while you have one CH. So for that CH you are getting a positive peak over here, and for all the other four CH2 you are getting negative peaks. So correct option is option 1. You can check any of these option, you're not getting more than like 4 CH2 in any of them. Over here you have CH3, then CH2, then CH2, and then CH2, and here you have CH, right? So you should get two positive peaks over here and three negative peaks. That is not possible, that is not what you are getting. So that's why this is not correct option. Similarly you can check for others also. So correct option is your option number 1, right? So let's talk about the next one. Right, so let's talk about this one. It says that in mass spectrum of 1,2-dichloroethane, approximate ratio of peaks, that is M by Z values, are given to you. Like three values are given. So this is 98, then 100 and 102. Okay, so just first let's draw the structure of the compound. So 1,2-dichloroethane. So ethane means two carbon, and you have 1,2-dichloro, so two chlorines over here, and this will be CH2 CH2. Okay, so this is 1,2-dichloroethane. Now we have to tell about the peaks. Okay, so you have M peak. Okay, M peak is at 98, then you have M plus 2 peak, because that is 2 units more than that, 98 plus 100, that is at 100, and M plus 4 peak. Okay, because you have 98 plus 4, that is 102. Okay, so you have three peaks over here. Now few things you should know depending upon these peak ratios. So when you have one chlorine, okay, only one chlorine, if there is in your compound, if you have only one chlorine, then you will get like at that time you are going to get M peak, okay, and M plus 1 peak. So these two peaks you are going to, sorry, M plus, yeah, M plus 2 peak. Okay, because the mass of chlorine is like we take 35 and 37, right? So that's why there will be difference of 2 units. So M peak and M plus 2 peak, both peaks will be there, and the ratio of them will be 3:1. So that is when you have one chlorine. Now if you have two chlorines, okay, so if you have two chlorines, in that case you are going to get M peak and M plus 2 peak, as well as you will also get M plus 4 peak, right? So all these three peaks you are going to get. And why you are going to get? Because if you consider both of those chlorine as Cl 35, then you are going to get M peak. If one of them is 37, then you will get M plus 2 peak, and if both of them are 37, then you are going to get M plus 4 peak, right? Now the intensity ratio of all these peaks are of order of this ratio, that is 9:6:1. How, from where this ratio and this order came? Actually this all is calculated depending upon the relative abundance of all these isotopes, right? So one more information which I want to tell you is, let's say your compound has bromine, okay? So if it has bromine, in that case, in the case of bromine, you will be having like the intensity ratio of M and M plus 2 peak. Your intensity ratio for them will be 1 is to 1, okay? So if you have bromine, the ratio will be 1:1. If you have chlorine, then your ratio will be 3:1, okay? So that's what you have to remember, and mass spectral questions can be done based on the ratio of these peaks, right? So that's all for this video, for this question. Let's move on to the next one, right? So let's talk about this question, and over here it says that the correctly matched structure of carbonyl stretching frequency, right? So they are asking about the carbonyl stretching frequency, and if you can see in this, you have three different molecules, and you have to tell about which is the correct match for them, okay? So to solve this question, you have to remember one thing, that in case of your gamma lactones, okay, in case of your gamma lactones, they show IR at 1770 centimeter inverse. This you have to remember, okay? Now, like see, gamma lactones are usually asked in exams, so this thing you have to mug up, you have to remember, right? So how does this gamma lactone look alike? Actually, it looks something like this. So this is your gamma lactone, okay? So this molecule will show your IR band at 1770. So that means P will be matched with your Y. Okay, so I'm just writing over here P. So P is Y. Now if you can see in R what is happening, it is also same as gamma lactone, just a carbon double bond is over here, carbon carbon double bond, and that is also in conjugation with this carbonyl bond, okay? So always remember this thing, that whenever conjugation increases, okay, whenever conjugation increases, your IR band will decrease, okay, your IR value will decrease. And one more thing you can say, that if conjugation increases, your bond order also decreases, or your bond strength decreases, okay? So like this you can like correlate them. So your R will have IR lesser than what gamma lactone is having. So that means R will be having lesser than 1770. So that is your X, okay? So X will be your related to R, and one is only left, that is Q, and in that conjugation is not there due to carbon carbon double bond, although conjugation is there due to this oxygen, but that is also there in this P and R, okay? So that doesn't count over here. So in Q it will be having higher value than P and R. So Q will be having Z. So Q is over here. So we have option number 1 as the correct option. P is like P is connected to Y, is Q with Z, and R with X. So like this, the correct option is 1. All right. So let's talk about the next question. So in this question over here, it says that the spectroscopic technique that can distinguish unambiguously between trans 1,2-dichloroethylene, it should be ethylene, okay, and cis 1,2-dichloroethylene. So what is your trans 1,2-dichloroethylene? So basically this is your trans 1,2-dichloroethylene, okay? So this is what your trans 1,2-dichloroethylene is, and cis one will be like this, okay? So cis 1,2-dichloroethylene is something like this. So you have to distinguish among both of them. So see, among all these four all these four spectroscopic technique, only microwave spectroscopy technique is that which gives like microwave, you will only those molecules who have permanent dipole moment, okay? So if permanent dipole moment is there, then your molecule will be microwave active, otherwise it will be microwave inactive. Means whenever you put a permanent, like if you put a like non-polar molecule inside microwave spectroscopy, you won't get any signal, okay? So this is the best way to distinguish between these two molecules, because in this molecule, this one is this cis one is having a permanent dipole moment, okay, whereas trans one is not having permanent dipole moment, okay? So the dipole moment is different for both of them, so that's why you can easily distinguish both of them based on this microwave spectroscopy, right? So this was the correct option for this. Let's move on to the next question. So this question, it says that a compound with molecular formula C4H6O2 gives band at 1770 centimeter inverse in IR spectrum, and peaks are at these 4 places, 1, 2, 3 and 4 places in carbon 13 NMR, that means it has four different kind, sorry, that means it has four different kinds of carbon. Okay, so four types of carbons are there, and you have to tell the correct structure of it. So based on your carbon NMR, that is very difficult to identify for this compound, because for that you must understand, you must know the values of carbon shift, right, chemical shift for carbon NMR. But if you look upon the IR data, you can easily tell the molecule. Right now only last question I discussed that for gamma lactone it shows IR at 1770. So just find out which one is gamma lactone over here. So I told you that gamma lactones look something like this. You have a 5-membered ring like this and this. Okay, so this you have a ester linkage like this, right? So that is only possible in option number C. So option C becomes your correct choice based upon your IR data. So you don't have to worry about anything. Always remember that IR spectrum value for gamma lactone. That is going to help you in lot many questions, right? So let's move on to the next one. For this question, it says that the ratio of relative intensities of the carbon signal in first order carbon 13 NMR spectrum of CdCl3 is. Okay, so you have CdCl3 molecule, and if you guys know that how to calculate how many number of signals you are going to get, how many number of peaks you are going to get. So to find out, you have a formula that is 2Ni plus 1, right? So yeah, so this is one. So I value for deuterium over here, because deuterium will split carbon NMR, because that is directly attached to carbon. So deuterium over here, I value for deuterium is 1. Okay, so let's put 1 over here. So we have 3 deuterium, so 2 into 3 into 1 and plus 1, so overall you are going to get 7. So that means you are going to get 7 peaks. So in option A you are getting only 5 peaks, in option B you are getting 4 peaks. Just count them. So 1 2 3 4 and 5, right? In C you are getting 7 peaks, and in D also you are getting 7 peaks, right? Now option C will be correct if I value would be, if I would be 1 by 2. Okay, so in that case Pascalian triangle is followed. So sorry, Pascalian, okay, so Pascalian triangle is followed, and in that case option C would have been correct. But since I value is 1, so in case of I value 1, if we have I value 1, then we have non-Pascalian case. So in that case we have different values for, like we have different values for the peaks, the intensity ratios are different for them. So that's why C cannot be correct, option D is the correct option. Okay, so that thing that you have to see that whether your I value is half or not. So for I is equals to half, you have Pascalian value, that was in option number C. But since you don't have to deal with I half over here, in this case, in this particular question, you have I is equals to 1. So that's why non-Pascalian triangle will be followed, non-Pascalian intensity ratio will be followed, not Pascalian one, right? So that was for this question. Let's move on to the next one. So let's talk about this one. Over here we have three compounds given to you, and 1 2 and 3. So first one is your 5-membered ring having a negative charge. Next one is your is a 6-membered ring, and next one is your 7-membered ring having a positive charge. So if you'll see, the first one actually is something like this, that is something like this. Okay, so negative charge is over here, and this is like this, and that will go under resonance to give this type of structure. Okay, so then negative charge will come over here like this. So basically it looks something like this. B, you all know, that is benzene. Okay, and C is your, yeah, so it is something like this. Okay, yeah, so it is something like this. Now one thing you have to remember, that all these three are aromatic. Okay, so all are aromatic. So aromaticity is not the case over here. So how to find out chemical shift value? So first thing which you remember, if positive charge in a ring, if positive charge in ring increases, then outer protons become de-shielded. Okay, de-shielded. What is de-shielded and what is shielded? For that, and when the proton become de-shielded, chemical shift goes downfield. Okay, so what is downfield and upfield? So in a chemical shift table, if you have value from 0 to, let's say, any value, so this is called downfield. Okay, so downfield means the value will increase, chemical shift value will increase, like it is 2 4, let's say. I'm just labeling it like that. Okay, so yeah, so whenever you have positive charge, whenever the positive charge in ring increases, then outer protons become de-shielded, and hence they will go downfield. Downfield means more delta value. Okay, so with delta value, that is chemical shift value, will be more for them, for downfield, again for downfield protons. So over here in the third one, we have these protons, outer protons, and they will be de-shielded, and due to de-shielded, their chemical shift value, they will be giving downfield value, and their chemical shift value will be highest among all of these, because positive charge is more in third only. Okay, obviously positive charge is shown over here, so that's why we can say that positive charge is highest in third. Okay, so that's why it will show I'm just writing out the chemical shift, like the chemical shift order. So third will have highest chemical shift order, right? Then comes the second one, because there is no charge in it. And then comes the first one. Why? Because first one is having negative charge. So whatever you have studied for positive charge, just reverse it out. So whenever negative charge in the ring increases, then outer proton become shielded over there. Okay, so negative charge will make outer proton shielded. Okay, so they will become shielded, and hence they will become upfield, relatively upfield, and hence less delta value, right? So that means one will be having lesser delta value. So in which option? First is having least delta value, then comes second, and then comes third. So correct option is your option number A. So like that, you have to do these kind of questions in which you are given with the chemical shift and all those things regarding the ring type of compounds, right? Okay, so let's talk about the next one now. Over here in this question, it says that an organic compound having molecular formula C10H14 exhibit two singlets in proton NMR spectrum and three signals in carbon 13 NMR. What does this mean? That how many types of hydrogen are? Two types of hydrogen and three types of carbon are there. Okay, so you have two types of hydrogen and three types of carbon in this particular compound. You have to find out the compound. These are the simplest kind of question which can be asked from this particular topic. So in the first one, just try to find out the plane first. So this is one of the plane, and this is one of the plane which can, oh sorry, it should be like this. Okay, so this is one of the plane, it should pass something like this. Yeah, so now these I'm just labeling now carbons. Okay, so this is carbon number A, this will also be same, so this will also be same, and this will also be same. So all are of same kind. So four kind of carbons, then B and B, so and this C. Okay, so C, 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 and C. So carbon three kind of, I'm just writing down how many carbons are there. So three types of carbons are there in this particular molecule. And how many types of hydrogens are there? So hydrogen will be over here, so I'm labeling hydrogen with 1 2. Okay, so this is one kind of hydrogen, this will also be the same kind of hydrogen, this will also be same kind of hydrogen, this will also be same kind of hydrogen, and this will be the second kind of hydrogen, because here also will be having hydrogens, right? And no other hydrogen is possible. So hydrogens are two types of hydrogen are there in option number A. In option B, let's see. So we can draw a plane like this. A plane is possible like this, right? So now let's see how many types of carbons are there. So carbon A, carbon A, carbon B, carbon B, carbon C, carbon C, carbon D, then carbon E, carbon F, and carbon G. So how many types of carbon we have? We have 7 kinds of carbon in this particular molecule. And how many types of hydrogen? So one, right? Then you have two kind of hydrogen, then you have 3 kind of hydrogen, you have 4 kind of hydrogen, because no other plane is possible. So 4 kind of hydrogen. So hydrogens are of 4 kind in this particular case. Let's talk about option number C. So a plane is possible like this. So when you draw a plane like this, how many types of carbon are possible? So A, B, right? C, D, and E. So carbons, how many kind of carbons are there? 5 kind of carbon. Hydrogen, let's see, so 1, then 2, and 3. So how many kind of hydrogen are there? So 3 kind of hydrogen, right? Just draw the plane and see how many things are there on the other sides of this. Okay, over here a plane can be possible like this. This kind of plane is there. Now how many types of carbons are there in both the sides? Just name them. So A, and B. Okay, basically one more line is possible, one more plane is possible like this. So basically this is also same. So A. Okay, now this will be B, this will be C, and this will be D. Okay, so four kind of carbons. And how many kind of hydrogens are there in this particular molecule? So we have one and one. Okay, so these are of same kind, two and two, then three and three, and this will be same. So hydrogens are of three kind. So only option which satisfies the given data, that is 2 hydrogen and 3 carbon, is your option number A. So like this you have to find out, identify, and do these type of questions. These are very simple, very scoring kind of questions, right? So let's move on to the next one. Alright, so let's talk about this question. It says that consider the following statement for 18 annulene, and the statements are: it is aromatic. Second says that the inner protons resonate at delta value 9.8 in its proton NMR spectrum. Third says that it has 6 proton in the shielded zone, right? So this question I have already solved on my YouTube channel, and here is the link for that. So click on that I button and you will get link for that, right? So I have just given the link for this. Watch that video on annulenes and that. So there you will get the answer, and I expect that you will watch that video and try to solve this question and tell me the answer. Okay, so I'm expecting your answer in the comment section. So try to solve it out and tell me what is the answer for this question. Okay, I am just moving on to the next question, leaving this question behind. Okay, so I am expecting your answer for this particular question. Try to find it out and try to answer me, right? Let's move on to the next one. All right, so let's take the last question for this video, and it says that the organic compound having molecular formula C15H14O exhibit following proton and carbon NMR spectral data. So you have this spectral data over here. Proton NMR is at 2.4 singlet and 7.2 doublet and 7.7 doublet, right? So basically three types of protons you have. Three types of protons you are having in this particular molecule. And how many kinds of carbon you have? So 1, 2, 3, 4, 5, and 6 kind of. So 6 kind of carbons you have for this particular molecule, right? So let's see in the options. See, first step is to, before going into the chemical shift values, before going into anything, just find out that how many kind of proton and carbons are there. So in option A, if you draw a plane like this, a plane passing through this, so how many kinds of hydrogen you have? Just find out the hydrogen. So you will be having hydrogen of this and this will be of one kind. Okay, these two hydrogens will be of second kind. So two types of hydrogen till now. This is of the third kind, so three types of hydrogen. This is of the fourth kind, so four kind of hydrogen, and this is of the fifth kind. So total 5 kinds of hydrogen. Okay, so 5 kind of hydrogen we got for option number A. In option number B, draw the plane. Plane is possible like this. How many kind of hydrogen? So we have A. These two are of same kind of hydrogen. Then B. Okay, so these are of same kind of hydrogen. Then C, these are of same kind of hydrogen. D, right? So we got, till now we got 4 types of hydrogen. And if we don't consider the, like, see since it is a single bond, so you can consider this B. So this will also be of same kind. So this will also be B, and this will be C. So this will be also be C. So how many kinds of hydrogen we got? So 4 kind of hydrogen we got in option number B. In option number C, it's pretty simple. No plane, nothing is there. So how many kind of hydrogen? A. Then you have B, C, D, E, and F. So we have 6 kind of hydrogen in this particular option number C. Option number D, draw a plane and see how many kind of hydrogen are there. So A. Okay, and then you have so you have B and you have B. And since this hydrogen, this one and this one will be of same kind, so this will also be A and this one also be A, because this is single bond, right? So you can draw this molecule in this way also. You can draw the same molecule in this way also, that doesn't matter. Okay, so yeah, you can draw this in this way also. So in this way, now the thing is same only. This is same only. You can now interpret them more easily. So these are of same kind. Okay, so A and B, right? And C. Similarly over here, if you want to do, so this will be B and this will be also B and this will be C and C. So 3 kind of hydrogen is in option number D. So basically you don't have to look upon chemical shift value. You don't have to go to there. You don't have to think about anything like chemical shift of carbon and anything. You just did the first step and you easily got it. So correct option is your option number D, right? So in this way you can easily do questions, you can easily solve them out, and you can get answer very easily. Okay, so that's all for this video. I hope you guys liked it. I tried to bring about around like 10-12 questions from this particular topic because it was very important, and I have already taken these topics in my special classes. But I just wanted to make sure that all the students get benefited from it. Since it's high time, I want all of you to know how to solve questions, especially from organic spectroscopy, right? So guys, that's all for this video. I hope you guys liked it, and if you like this video, give it a like, subscribe to the channel if you are new to this, and share this video with your friends so that most of you get benefited by this content, right? I hope this video will be helpful for you in your upcoming CSI NET exam, and if you are watching this video after your CSI NET exam, then also this video is going to be helpful in your upcoming exams, right? So any of the exam, if you are preparing for CSIR, okay, either of for your gate, then also this video is going to be very helpful, and also for your IIT jam. Okay, so in any of these exam, if you are preparing, or any entrance exam, any uh, like university entrance exam for PhD or MSc, this video is going to be very helpful for you, right? So that's all for this video. Thank you so much for watching. Have a great day. Bye bye.